Hi and hello. In this next lesson, we're going to talk about synthetic division. Synthetic division will end up being a shortcut of a way we can divide polynomials. We'll talk about the specific rules when we're allowed to use synthetic division and how to do synthetic division in just a moment. First, I'd like to talk about synthetic substitution and how we can evaluate polynomials. So in the past, we've used almost exclusively the standard form of a polynomial. Standard form of a polynomial is when we list all of the terms from highest degree to lowest degree. If we want to evaluate a polynomial in standard form, we can just plug in our x and then evaluate each term and then find the sum. So negative 2 cubed is negative 8. 4 times negative 8 is negative 32. Negative 2 squared is 4, and 3 times 4 is 12. 2 times negative 2 is negative 4 plus 1. And then find the sum. Negative 32 plus 12 is negative 20. Minus 4 is negative 24. Plus 1 is negative 23. Another way we can write the polynomial is called nested form. And this, written in nested form, a polynomial will involve just multiplication and addition, no exponents. So let's talk about how to build nested form. What I'm going to do is I'm going to separate out the addition and I'm going to factor. These three terms have a common factor of x. So that'll turn that 4x cubed into a 4x squared, the 3x into a the 3x squared into a 3x, and the 2x into a 2. And then I will just repeat. I'm going to separate out the addition. And then I will factor out a common term. So 4x squared and 3x share an x that I can factor, which will turn 4x squared into 4x and 3x into 3. And then we could repeat as long as we still had an exponent higher than 1, but this is called the nested form of a polynomial. So if we want to use nested form to evaluate, we'll plug negative 2 in for each x, and then we will multiply and add, multiply and add, multiply and add from inside out. So 4 times negative 2 is negative 8. Negative 8 plus 3 is negative 5. Negative 5 times negative 2 is positive 10. Positive 10 plus 2 is 12. 12 times negative 2 is negative 24. And negative 24 plus 1 is negative 23. So using nested form gets you to the same result. The work is a little more repetitive, but there's no exponents to deal with. So we can lay out our nested form of evaluating polynomial in what's called synthetic substitution. The way we can recreate this work is first by listing all of the coefficients of our polynomial. So if I want to plug negative 2 again into 4x cubed, 3x squared plus 2x plus 1, I will first list all of the coefficients of the polynomial in standard form, 4, 3, 2, 1. In a box off to the left, I'm going to write down the number I want to plug in. I want to plug negative 2 in. As we go, we are going to add down, and we are going to take whatever term we have here, multiply it by negative 2, and move it diagonal and up one space. So 4, I have nothing to add to, so I will bring my 4 down. Now I'm going to multiply it by negative 2. 4 times negative 2 is negative 8. And we will continue. 3 times, and we will continue. We will add down and multiply the result up. 3 plus negative 8 is negative 5. And then I'll multiply again by negative 2. Negative 5 times negative 2 is 10. And then I will add down. 10 plus 2 is 12. 12 times negative 2 is negative 24. and add down negative 24 plus 1 is negative 23. So that is the process of synthetic substitution. It's the exact same work of evaluating a polynomial as using nested form. So now let's compare synthetic substitution to long division. I've got a different polynomial I want to do some long division with, and then I'm going to evaluate at p of 2. So let's start with the synthetic substitution. Again, I'm going to list my coefficients of my polynomial, 3, 4. I have to be careful to include the 0 term, just like we were doing with long division, because there are no x's, 10. And then off to the corner, I want to plug in 2, so I'll put 2 into a box. Add down. 3 has nothing to add to, so 3. Multiply by 2 is 6. Add down. 4 plus 6 is 10. Multiply by 2. 10 times 2 is 20. Add down. 0 plus 2 is 20. Multiply by 2. 2 times 20 is 40. And add down, we get 50. P of 2 is 50. Now let's compare this. I'm going to divide the same polynomial now by x minus 2. So I'll put my x minus 2 outside of our division box. Now we'll put the polynomial I'm dividing inside. 3x cubed plus 4x squared. Again, I need to include a 0x term just to make sure my like terms will all line up. All right, to get my x to match up with a 3x cubed, I have to multiply by 3x squared. We'll multiply by 3x squared and subtract down. 3x cubed minus 3x cubed is 0. 4x squared minus negative 6x squared is 10x squared. Bring down the next term. Now I need to get my x to match up with a 10x squared. So to get those terms to match, I can multiply x by 10x. So I'll have 10x squared minus 20x. And if I subtract down, 10x squared minus 10x squared is 0. 0 minus negative 20x is 20x. And I'll bring down my 10. And again, finally, I need to get my x to match with a 20x, which I can get by multiplying x by 20. I'll multiply my entire divisor by 20. And then we subtract down. 20x minus 20x is 0. Those should always cancel. 10 minus negative 40 is 50. So our quotient, our result, 3x cubed plus 4x squared plus 10 divided by x minus 2 is 3x squared plus 10x plus 20 with a remainder of 50. Now what's interesting to note is all of these numbers are the same. 3 for 3x squared, 10 for 10x, 20 for 20, 50 for the remainder. So under certain circumstances, we can use synthetic substitution to divide polynomials. We can use synthetic substitution to divide when we are dividing by something of the form x minus a. So let's run through 2 quick examples of using synthetic division. First, we need to list all of our coefficients of our polynomial that we are dividing. 7 for my x cubed. Be careful, I have no x squared term, so I'll put in a 0. Negative 6 for my x, and then 9 for my single term. In a box off to the left, I will put the opposite of this number. I'll put in -5. And again, add down, multiply. Multiply up. So 7 has nothing to add to. So we have 7. And then we will multiply by -5. 7 times -5. 7 times -5 is -35. And then we add down. 0 plus -35 is -35. And again, multiply up. -5 times -35 is positive 175. Add down, and you get 169. Now we will multiply again by -5. 169 multiplied by -5 is -845. And add down, and we have -836. This number at the end, 50, was our remainder. So this -836 is the remainder. And then each term just builds up in degree. Start with the constant term, and then the x term, and then the x squared, just as long as we need to go. So -836 is our remainder. 169 is our constant term. -35 is our x term, and 7 is our x squared term. So that is the quotient of 7x cubed minus 6x plus 9 divided by x plus 5. Let's do one more together. I've got 4x to the 4th minus 3x squared plus 7x plus 1/2, and I want to divide it by x minus 1/2. So again, I will start by listing the coefficients. 4 for my x to the 4th term. I need to be careful. I'm skipping from x to the 4th to x to the 2nd, so I need to include 0 for my x squared term, for my x cubed term, -3 for my x squared, 7 for my x, and then 1/2 in a box off to the side. I'm going to put the opposite of this number, so positive 1/2. So again, we will add down. 4 has nothing to add to. Multiply by 1/2. 4 times 1/2 is 2. Add down. 0 plus 2 is 2. And then multiply by 1/2. 2 times 1/2 is 1. Add down. -3 plus 1 is -2. Multiply by 1/2. -2 times -1/2 is -1. Add down, and that's positive 6. Multiply by 1/2, and that's 3. And then add down, and we get 3.5. Again, we will start with this term at the end is our remainder, so we'll have 3.5 over x minus 1/2. 6 is our constant term. -2 is our x. 2 is our x squared. And 4 is the x cubed. We would just continue building in degree as long as we have more terms. So that's how we do synthetic division. It is a shortcut for division whenever we want to divide by something of the form x minus a. One question to try to take away from today is, can we use synthetic division by x squared plus 3? And the answer is no. Again, based on what we've seen today, we can only use synthetic division to divide by a polynomial with a leading coefficient of 1 and a degree of 1. So the reason we can't divide by x squared plus 3 is because of the squared. Thank you for watching.